Let me share the screen. Are you guys able to see my screen now?
Yes, we can.
Okay. Some of you missed the class yesterday, so I'll just take 5 minutes to go through that so that it serves as a revision, and then we'll get started into the specifics of code. Okay. So yesterday we discussed about how the computer runs the program. So basically, there are three components, which is your chip, and then we have RAM, and then we have hard disk. So remember that we have three levels of memory. One is at the cache level, and since it cannot be in terms of GBs because it's too costly to produce, we added RAM, which is again costly to produce, and it also has it is based on some of the RAMs are based on static electricity, which means that if you switch off the computer, it gets although the signals inside that gets lost. That is the reason we have a magnetic disk. It was magnetic disk. Nowadays there are different technologies to do that, but we can store data in between the switch off and switch ons. Even if you switch off the signals, you can retrieve the signals. That is the reason that you have all these pen drives, memory cards, and things like that. Okay, so these are the three components, and how computer gets started is when you switch on, it reads a master boot record from the hard disk, and it loads the operating system, and then onto the RAM, and then there are several programs which are waiting to be executed. It executes them, and CPU is waiting to execute. So this is an analogy that we saw, that how we kind of send the signals into the CPU so that we can orchestrate the signaling into the chip. So that is the business that we are in terms of programming. So programmers try to control the signals. Of course, we cannot control on the device. So we build various ways to do that. So first is using people try to use machine code so that you can feed in ones and zeros to the CPU, and it is too difficult to remember, debug machine code. So people started developing something from which we can generate the machine code, which is nothing but assembly code. It looks like this. And since there were a lot of chips in the market, and every chip had different versions, each of these chips has different sort of assembly code, which cannot be remembered by developers. And then it's then we went to one more level where we can generate this assembly code using some other language, which is like basic COBOL, C, and things like that. So that is the reason we when you write a C program, you compile it. The compilation process has several steps. The final output is object code, which is the typically ones and zeros, or we call that executable binary. So that gets translated to signals onto the CPU. So that is the third level of automation that we are trying to do. Our overall goal remains the same thing because we're trying to orchestrate the signals on the CPU. So you can see in this example, we have different assembly code that is generated for a single statement of the code in C. So, uh, so this is how we arrived at C++. Now, instead of thinking in terms of how the computer thinks, now we have tools to automate all this assembly code and object code. So people wanted to transfer the ideas that the way that humans think, and that is how the object-oriented programming languages came into picture, such as Java. And we also discussed about cross compilation. Cross compilation is nothing but you write a program on your machine, and then you can flash your uh, the final code, which is object code or the machine code, onto the embedded system. So examples are all your embedded systems like which doesn't have monitor, keyboard, or enough memory to support all these peripheral device, such as mobile towers, even the watches that we use, smartwatches, and a radio on the car and things like that. So that is the cross compilation. And the problem that we are trying to solve is that there are two things which are happening in the industry. One is the there are several operating systems, and each of these operating systems have different versions, like Linux, Windows, and then Mac OS, and each of this has several versions. So in order to cater to this, so people built, we shouldn't be aware of, or the programmer should not be burdened with knowing the internals of operating system. So they built something called as virtual machine. This virtual machine is nothing but interpreter. It is not the virtual machine that we use in terms of cloud, or VMware, or operating system on top of operating system. This is a interpreter which is called as virtual machine, which does the translation of generating the byte code which looks like assembly code, and it translates to the machine code of that particular hardware plus the OS. So that is the reason that you can now forget about what is the underlying hardware and underlying operating system. You can simply code anywhere and uh, put the object code anywhere that you want to run. So that is what is called as program portability. So because you can copy paste the programs. So that is about how we arrived at Python-like languages. Even Java uses virtual machine. So this is the process. So we have got a compiler which compiles the program, Python code or Java program, and which generates something called as bytecode. So this bytecode is not exactly the assembly code. It We will see it in coming sessions. So this bytecode is then translated to machine code, um, step by step using interpreter. So that is what we looked at yesterday. And uh, today, let's look at some of the basic data types or the data structures, or we can say. And yeah, let us get started. Any questions so far in in the revision? Okay, let us get started. So yesterday we also installed the Python, and I asked you guys to install any of the um, code editors, that is IDEs. They look like this. This is Visual Studio. You can use anything like PyCharm or IntelliJ or anything of your choice. I prefer Visual Studio, so I have that here in my laptop. So if you haven't, please install it today. For today's class, we might not require that because you can do it on interpreter. So if you just go to the command line and then type Python 3 or Python, so it will open up something like this. This is nothing but the Python interpreter, which is nothing but what we saw here. Virtual. So this is waiting for an instruction to be executed. For example, I can say some, and this gets executed. So this is using the interpreter. Of course, we cannot use the interpreter always, because once we quit the interpreter and I go back and try to use the variables or something like, let me show you, a is equal to some, and then if I print a, it prints 5. But when I invoke it again, if I try to print a, it is not found, because you have exited the shell of that particular session, and uh, it cannot remember. So how do we make it remember? That is the reason we write the source code on a file which is stored on the hard disk, like this. For example, this is on hard disk. That is why you can navigate to the code, and then you can see that. This is the reason that we write files. We do not open up interpreter or compiler and then start writing the code, right? So yeah, for today's class, this is enough, but please try to install VS Code or PyCharm. Okay, so let us get started with the basic constructs of the language. So we will look at all the data types because it doesn't take a lot of time to learn all of them in one shot. And also I'll give you some examples in real world so that you don't forget. So let us look at what are the data set types and why do they exist. So as we discussed in yesterday's class and even today in revision, so what we are trying to play with is the CPU, and CPU has an instruction pointer, always trying to move its pointer to the next instruction. So you have RAM, and then on RAM you have something like a grid. So grid of memory, and in order to take control of this memory, we need some way to do that. So for example, if you're coming from C++ background, we have data types like integers, float, double, character, char, string, and all this. The underlying idea is to say that I want this long memory, or in this grid, I need this much space. That is the idea. And then we interpret, or the compiler interprets, this is an integer and float. But when you put it onto the RAM and CPU reads it, it doesn't care whether, it doesn't even know that it's an integer, because it operates on the grid cells of the RAM. So that is the reason that we have data types. It's like managing, say, an apartment. So if you have 1,000 houses in the apartment, there is, and if you want to say find out, or if you want to collect the dues, or if you want to collect the maintenance, so if there is no online way of doing it, you have to uh, send somebody and try to get the bills collected, right? So it's like that. So it's a row houses, and then you try to okay, this floor or this particular block. So that is how you sort of imagine the spaces in RAM. So it is a grid. So since it is a grid, we cannot, there should be a way to address them. So this is the way to address them. For example, my num is a variable and phi is a value. So how do I access phi? Using this variable, and these variables have the addresses. So and there are pointers as well, which we will not discussing this, because in Python we do not have pointers, but we have something similar to that. We'll discuss that. So that is the reason that the data types exist. So just remember this, we have grid of memory, and we need a way to access those memories as we need. So we store the data, which is nothing but some of the variables, which is again the signals, and then that needs to be read by the CPU. So that is the reason why data types exist. And then what are the data types in Python? So there are several of them, and why there are several of them, we will discuss the constraints and how do we use them. So important thing is to uh, know, or to develop a skill to use the right data types. So we will look at that. So these are the data types that we have. We'll look at each one of them. So we'll so there are basic data types, for example, integers and float numbers. For example, a is equal to 2, which is an integer. So how do you know that it is an integer, or how does the Python know that it is an integer? Is because in Python everything is an object. So in C++ or C, for example, this variable is not an object. So what do we mean by object is, for now, just remember that object means it has data and it also has related function tied together. So that is an object. So how do we know this is an object, and how what are the operations supported in this particular object? Is there are some inbuilt functions. For example, you can say what is the type of A. So it says it's class int. So int is an object, and you can also look at what are the operations that is supported inside this data type. So you can, there is a inbuilt function called as dir, which means directory, or so similar command that you type on the Windows. If you type dir, it lists all the folders. So these are the um, operations that you can do on top of integer. Okay. So this is how you identify what is the data type of this. So let us look at this. You can convert it to bytes, you can convert it to real number, you can also extract the numerator and all these things. But now we don't require that, but this is how we generally do it. And in fact, you can change A to say something like this. Let us look at what is the type of this. You can see that the type of this is float. So these are numeric types. So I'm sure you know where to use this. For example, if you want to store pi, value of pi, it is a float. And then if you want to just put an age or some number, like number of the quantity, you can use integer. So this is very basic. And let us look at looking at what are strings, because these are uh, strings is nothing but collection of characters. So for example, I'll show you on the string s is equal to, so character is nothing but say one character, which is everything that we type and we do not see on the screen. For example, new lines, tabs, which we do not see. For example, I can type tab, but we won't able to see it. Invisible characters. Even that is a character. For example, now you can see type of S. It says this is a string. So there is no, in C we have something called as char, but here we do not have the basic inbuilt, because every string does the job of characters. So let us make it a little bit bigger. Char, and then I'll type something like this. Okay, so strings are nothing but okay. So characters put together. So what are the, so there should be some operations using strings, right? So let us look at what are the operations. You can simply look at operations like this. You can swap the case, you can make it upper. For example, I can use s dot upper, and it converts all of these characters to uppercase. And you can also split the character, and you can also, each of these operations you can try yourself. So this is the basic nature of the character string. So you can also access some of the elements. For example, you can access the 0th element. So remember, in computers the indexes start from 0. So you can access this second one. From second one is nothing but the third here. Second one actually is 1. So you can look at the characteristics of string. You can try to access these elements one by one as well. So we'll look at examples later. So this is string. String is nothing but, you can, in real world, you can imagine that you have a bracelet, you have necklace, things like that, wherein you cannot simply remove one one of these links or one of these balls from the necklace, right? So that is the analogy where you cannot modify it. So there are two types of data in terms of readability and writability. So there is mutable and there is immutable. So strings are actually immutable. So you can um, so you can see that there are no operations which can remove one character from one character or any one of these items from strings. That is because strings are immutable. That means it is just read-only memory. Just like in if you're coming from C++ background, it goes into the read-only section of the code. So you cannot modify this. So how is there a way to modify this? Of course, you need to create a copy of the string without that particular character. So you can do that. So that is about mutability and immutability. And this is important to remember in next data types. Let us look at list. List is nothing but, it's like an array in C++ and Java. So the only difference is that you can store anything in the list in Python. So let us look at list here. For example, create my list is equal to, this is how you create an empty list. So this has nothing. How do you know that it's a list? You can look at the type of this and we have got a list. And let us look at the operations involved that we can do on top of list is this. These are the operations. Yeah, do not worry about this double underscore operations as of now. We will come to that when we cover object-oriented programming. So there is append, there is clear, copy, count, extend, and it is self-explanatory, but let us try to do something using one of this. So you type my list again, you can see that I have appended one element into this. You can also initialize my list using actual list, for example, 2, 3, 4, like this. So this is one way of initializing, and we are appending. So in terms of mutability and immutability, so list is something which we can mutate or which you can modify. So what does that mean is, so we were talking about RAM and the grid of memory that we have, and we're trying to play around with that, right? So there is a inbuilt function where we can get the address of a particular um, string of memory or the beginning of that memory. For example, when we initialize my list, so we asked computer or the interpreter to, when you execute, I need this big space. So we have got that space, and the beginning address of this is this particular thing. So this is not the exact address of the RAM, because this is an ID or identifier which is on the virtual machine. You just remember that we have virtual machine in between. So virtual machine is the one which keeps track of these addresses. So virtual machine has this address, and it is actually tied to the address of a RAM. So this is somehow translated inside that, but we don't have to worry. And for example, let us look at, okay, let us try to do one more thing. So we can also append something like, now I have list of only integers. You can also add string here. You can see that we have added the string, because list is something which is able to store any sort of data types. You can, in fact, have list of list, for example, like this. So you can say that there is a list and there is a list inside that. In fact, you can combine these data types. So you can also have dictionaries, which we'll see in a while, so, and things like that. So this is a mutable type, which means that I can remove. Um, I think there is something called as remove here. So yeah, when you're not connected to internet and you want to find out what are the functions inside this, dir is the one that you can use, because usually we Google say, how do I remove some number from a list when you are facing a problem. So instead of that, so if you do not have the internet, so you can do this. This is coming from the implementation documents of this particular data types. So that's a nice way to do it. Let's try to remove 3. You can see that 3 is removed. So this is how the operation works. Okay, we can also extend the list. For example, you can extend with, let me give the first list that we created, and you can see that the first list had just 2, and then 2 got appended here. So that is how we append the list. So extend the list. There is a difference between extend and append. Yeah, when you try yourself, you can see it more. So there is also insert. So you can insert in a certain location and things like that. There is count, which is nothing but the length of the count. So this is how the list is designed. So what are the use cases that we can use list for? If you want to iterate something and there is a requirement that those things change. For example, list of students, list of say items when somebody is checking out of the shop. So somebody purchased it, and then you have a list, and then you can also. So these are the like use cases that you can use list for. And more we program, will get used to that. You don't have to like think uh, for a second time that what is the list and its operations. It comes automatically as we program. Okay. Then there is something called as tuple, or it's some people also pronounce it as tuple. Tuple or tuple is almost similar to list, but it has one difference, which is it is not mutable. It is immutable, which means it's just the read only. Let us look at the operations. My tuple, I can create one. So this is a tuple or tuple. So how do you identify the type? This type. So this ensures that this is a tuple. So the reason that we use type is sometimes in a program, you can also check if this is type of this, do something like this. If this is the type, here is how you access the elements, things like that. So this is a useful function. And let us look at the operations that is inside tuple. We can see that there are only 2 of them, right? And there is, once you initialize tuple, you cannot do anything with that. So for example, let me try to you can, of course, you can access it like this, the first element and the second element. You cannot do anything other than creating a tuple and access it. That is because it is designed for certain conditions. For example, we might be we might want to store a GPS location. We might want to store say the relationship between the ticket and person, or a row from a database. So when you read something from database and you're trying to operate on top of it, you do not want to accidentally modify that row, right? Because you'll get a uh, uh, different outcome. So these are the examples. So accidentally modification means it is possible that you unintentionally modify it. So there are cases, say in a loop, or we could be writing a library which is used by another uh, developer, and he might be able to do something which he doesn't intend to do. So that is what I mean by unintentional modification. So this particular tuple is exactly same like a list when we look at it, but uh, it doesn't have any operations which we can modify. Okay, so that is tuple, and you can in fact recognize the tuple. If you print it, it will have this sort of braces. Uh, and for list, you have this sort of braces, square brackets. This is rounded brackets. So this is how we visually identify the types. We will come to that. So that is about tuple, and we'll discuss about something called as set. So set is an interesting thing. So this is how you initialize set. So this looks like dictionary if you already know a of uh, little bit of Python. So people generally think that, okay, since it has this braces, so I'll initialize like this. But once you initialize this, let us look at the type. So it says it is dictionary. So in fact, this is not the right way to initialize a set, because set and dictionary has same look in terms of braces. It has flower brackets. So the right way to initialize is using this. Now you can see that this type is set. The reason that you see the class is because the implementer of this particular set object or a class is using an object-oriented methodology, which is class, and that is why you see the class. For now, you ignore this and look at this. So this is a set. So what are the operations that you can do on a set? Let us look at that. And what are the use cases that we can come up with? So you can add a number. For example, let's look at from here. Add a number, clear it, copy, difference update. Yeah, these are a little bit advanced. When you start writing complex programs, you can use all of this. So, okay, so let us try to add a number or any element. In fact, you can add anything. So let us look at add. And you can see that you have flower brackets. Within that, we have two. You can keep on adding as much as you want. Okay, so this grows. So what is the difference between the tuple? What is the difference between how this is different from, it looks like list or it looks like tuple? What is the difference, right? So in any data type or structure, so the the image that you must have while writing this is we are working with a grid, which is nothing but RAM. And my set and the tuple and the list we uses uh, sequential memory. That means you can just block or it's just like coloring the notebook, right? So you just color the one line in the grid, one row in a grid. But in set and other some of the dictionary, so such cases, you do not have a way to or it is not a contiguous memory. It is not like you're coloring the row or you're taking picking a row inside that. So it is randomly allocated, and then you can access them. So who keeps the book tracking, or who does the bookkeeping of where these particular items are there? So that is done by the interpreter. And then the reason that we use this is the major difference is in list, if you want to search something, for example, my list one. So I'll try to search something. So how do I search something? There are different ways. So, but let us go step by step. Look at dir and see, is there any? um, anything which you can use for searching. So is there a find or something like that? So it's not there. So, but I can simply do something like uh, two in my list. So there are, if you do, so this searching, usually if you want to implement yourself, you will write a function, something like find or search. So in Python, there are similar interfaces of the functions, but this is one of the ways to search a number or search some item inside a list. So in fact, this works for all the data types in keyword. So we have a keyword which is somehow tied to that object, and then it does the searching. So if 2 is inside this, so it says it's true. So how did we arrive at 2, or how did we search 2 is that, um, so it starts looking from the beginning, and if it is found, it just returns true. So if you want to search, say, number 4, it looks at 2, 2 is not 4, and it goes here 4. So it is sequential searching. So it is like, if you want to say, if you want to search your cabin when you try to get into the train station, and the train is standing in front of you, but you want to you want to go to your particular bogie, or but that particular seat. Since we know that it is sequential, the train bogie numbers are sequential, like S1, S2, S3, like that. And we run towards that, right? So we look at every bogey's number, and then we get into that. We directly cannot run into, say, S4. So that is how the searching happens. This sort of searching is like called as sequential searching. So the effort that is taken to find a number is actually uh, uh, compute computational intensive. That means if you want to find a last number, you have to look at all the numbers from the beginning, because it's a contiguous memory and we do not have bookkeeping of where is what. But in set, it is not like that. So if you want to find something in set, say in my set, it simply returns the it directly goes to 3 and finds it. How this happens internally is a little bit advanced. It is called as hashing. So whenever we try to add something into set, we use some algorithm. It is called as hashing. So, and then we sort of hash that, and when we try to search, we again generate the hash, and this hash is translated to the memory that is in the RAM, and we find that particular memory in the RAM, and then we access that. So the way to access, or it is easier to access. So searching is simple in this. Even if you have 1 million items in this particular my set, you can add like probably add 1 million items here, like this. So in a loop. So not like this, of course. So, and then if you want to find some number, you don't have to look at all the numbers. You can simply go and ask for it, and it will give you. So how does it work internally is something called as hashing. We'll come to know about that. So that is the main difference between the set and list and tuple. Okay. Let us look at, yeah. So you can remember it by set is nothing but, okay, if you remember the maths, or if you are teaching your kids math, now you know that set is nothing but, and also on top of this, you can do set operations. So you have my set, for example, and then I can do my set 1 is equal to another set, so just 3, and you have, you can look at the operations. Of course, you can Google anytime, but if you do not have that, you can do something like union of my set 1 into my set. So this is the union, and you can also do intersection and things like that. So 3 is the common number between set 1 and the my set. So set operations are supported in this, and there's also a shortcut way to do intersection. For example, my set. So this is how you can um, do the set operations. So some number which is in my set but not in my set 1, something. So that is about sets. It is used for mathematical operations. It is you can use it for searching and things like this. So whenever we think of a data type, you should think about the operations on top of it. For example, how efficiently do we add, efficiently we remove some item, or how efficiently we search. Searching is something which should be on top of your memory, because searching is the most used operation, because when we have something in a data type or stored in any data structure, we try to search and do some operations. So searching is most common operations. So we should know how long it takes to search in all of these data types. So dictionary, we see all of these data types in day-to-day life. For example, imagine you have you go to this what is it called, clock room, in a train station, and you give your bag to the clock room guy, and so he stores it and he gives you some token. So when he come back, he doesn't look at all. Doesn't look at starting from everything. If he's an experienced guy, so he knows where this particular number is there. For example, 2, 3, 4, 5. So he knows that this particular box is right next to me, or on the next row, or something like that. So he goes and fetches that exact luggage for you uh, by looking at the number. So in order to translate this in terms of computation, so the key that he has given you, or the number that he has given you, is the key, and your luggage is actually the value. So let us look at that. So how does a dictionary look like? It just looks like set. It has flower braces. Do not get confused, or do not assume that it is a dictionary until you actually do it. For example, um, dictionaries are also called as maps. So you can do something like map, but do not use map, because map itself is an inbuilt function. For example, if you just see there's an function, but I'll just use map one. So this is how you create an empty dictionary. So as we saw earlier, let us look at type of this. It's a dictionary. It's a short form of dictionary. Okay. So what do we do here? So we can in fact store something like um, 1, 2, 3, 4, and then that's a token number, for example, and then say luggage. And with comma, you can also add as many as key value pair into this. So whenever we think of key value pairs, it is actually happening. In fact, you can see a lot of examples in our day-to-day life, if you observe. So just like the train example that we give, and for example, in fact, there are specific spaces that we keep items in our home, right? For example, we put the key in a certain place, and we keep the book in book rack and things like that. So these are actually the places and memories, and you know that okay, this is there. So those are the memory boxes, or numbers, which are actually not numbers but the locations in your head. Okay, so mm, dictionary is something which we use every day, and this is how we translate that into the code. I can say this particular token. someone else's luggage. Okay. And then I can look at that. So if I want to find my luggage location, I can simply say 1, 2, 3, 4. It's the string and extract that particular item. So this is how we access an value using a key. So what are the good examples of if you are designing, say, uh, a banking software, or you're trying to write a transaction module? Probably transaction ID is the one which you can use as a key, and so that you can directly jump into that particular transaction amount, which is a value, and then you can retrieve. For example, when you do the UPI transaction, you get a long string. So that is a unique string generated. The reason that is unique because you can actually search it. If somebody wants to search in his bank without this key, so it will be difficult, right? You have to look at all the account numbers, and then there are like crores of them. You cannot go from beginning and then search it, right? So you need to go to that particular location. So how do you do that? You generate some unique key, and you know where it is located. So that is how we search an item in a dictionary. In fact, this is widely used in our databases. And so, for example, if you heard of primary key, this is a, a key which is like hashed. When you hash that key, uh, we get that location, and we can fetch the value. So for all the searching operations which has key value, you can use maps or dictionaries. So you can think of a lot of ideas. And then what are the operations that you can do on the key, on the dictionary is like you can copy the dictionary from keys get, you can get all the keys, you can pop an item, that means remove one item. For example, I can do something like pop this key, which is nothing but it pops out, and you can see that that particular element is removed. In fact, you can also use something. Let me initialize it again. You can, without popping, if you want to remove, I think there is something called as okay, there is there is no specific function, but there is, can also do use a keyword which is delete, and you can simply say one, and it deletes that particular element or that row itself. So remember, maps or dictionaries are used for searching. Just remember UPI IDs, or primary keys in the database table. And yeah, just remember this particular example, which is like is a real life example, and you won't forget it. And if you go to a temple, it's the same thing. Instead of clock room, you'll have some place where you leave your slippers and get the token, right? Yes, it's the same thing. Okay, so that is about dictionaries. And as I told you before, you can also mix up data types. For example, I can have map with the key, say test, and I can add some new element, uh, which is a list. So if I look at map one, you can see that in this value, I can also insert any sort of uh, data type into that. So this types of you can do this mix and matching. In fact, we can also have uh, test map, a dictionary inside a dictionary as well. So this is very commonly used. We will look at this is our main dictionary, which is here, and then we have a dictionary inside that. So this is called as nested dictionaries, which will see if you're already working, or if you have worked with APIs, you can see that you might have heard about JSON files, YAML files, wherein we have certain structure, and there are dictionaries inside dictionaries. So we'll come to that while we make a project. So that is about dictionaries. So searching, insertion, removal. So just keep those things in mind. Okay. So that is about data types. Okay, I wanted to. So just remember that while making variables, do not use any of the keywords which are inbuilt for Python. So in fact, if you're using ID like this, if you're trying to use some keyword, it will highlight in a different color. For example, I can use a list. You can see that this is in blue and this is in green. Green means which is inbuilt. But if you do it on a plain notepad, you won't be able to see it. Yeah, so that is the use of ID as well. So do not use any of the keywords, but you'll become familiar with these keywords anyways as you program. So, and then, okay, and then okay, now we have learned about how do we uh, reserve the spaces in the RAM, and what are the intentions behind using different data types. So searching is one of the main intention. So keep that in mind, hashing in mind, UPID in mind, and then list, there is tuple, there is also something called as Boolean types. For example, true and false are Boolean types. So these things you don't have to remember because it's basic types. For example, integer you don't have to remember. You'll naturally know it. But these are the types that I wanted to show you, and we will use it in a while. So any questions in data types? Okay. Okay. Let us. Okay. I'll also give you some assignments where you can get acquainted with this, because from now on, if you do not get your hands dirty, you won't be able to learn, because it's like learning a musical instrument. So if you know Sarigama Padanisa, everybody knows Sarigama Padanisa, but everybody cannot play the instrument. That is because unless we practice, we do not know what are the errors, and if I get this error, how do I get rid of this, or how do I solve this? So you need to get your hands dirty. So I suggest fix a time. For example, maybe before joining the class, or soon after the class, or in the evening. Just fix that time, say 20 minutes to 30 minutes, and just do the assignments and look at the recording if you are stuck, and then proceed. And please feel free to send a message or call me as well, and then write it. So just get your hands dirty from now on. Okay. So once we have this, we'll write complex programs, and then we will understand how this data types we have learned to allocate the memory. Now we also will learn how do we write if-else conditions, loops, in order to access these parts of memory, and then putting things together will become a program. So in next class, we will actually start writing the programs with the proper logic. So these are the items that you will need to sort of memorize as of now. Any questions?
Nope.
Okay. Okay, great. We are it's already 8 o'clock now. Yeah, so I wanted to cover if-else statements, but no worries, we can cover it tomorrow as well. And then we'll cover loops. And just remember that we use loops very frequently in our day-to-day lives, but when we never put it on the program. So it is all the concepts that we learn in programming is already there in our real world, and we are hardwired to do it very easily. So we are just decoding our own thinking. That's it, nothing else. And we can even think very complex than the computers, right? So this is nothing difficult. So do not hesitate to start programming, because this 1 month, if you spend time, our thinking patterns change, and we become, some sort of um, informed thinker. Like, okay, why this works? Why it shouldn't work the other way? Such sort of logical thinking will naturally develop in this 1 month, and then it helps in all the walks of your life. So if you're discussing with a colleague, like how you are solving the bug and what is the solution for this bug, and things like that. So it gets very interesting if you know a little bit of programming. Okay, please get your hands dirty. If you are unable to install Python on your laptop, please let me know. I'll sit one-on-one with you and get these things installed. One is Python, another is your IDE. Okay. Okay, yeah, that's it. That's the thing I had in mind for today. Okay, any questions?
Thank you, Digant.
Yeah. Okay, let me stop sharing. Now, please do not hesitate to contact me. Like, do not think that I might be asking a stupid question, because here we are here to learn, right? So it's okay to ask stupid questions, and probably kids can do it faster than us. That doesn't mean that they're smarter. It's just that we haven't been introduced to that, right? So just ask questions. Do not hesitate to ask questions. Okay. This is the only place where you can be free while learning programming. Okay. Thanks a lot for your time. Okay. See you tomorrow.
Thanks again.
Thank you.
Thank you.